This is going to be the last lecture video. It's going to be the lecture video for section B9. And in B9, we're going to solve polynomial and rational inequalities. And the steps that it actually provides right here for polynomial inequalities, and as we'll see here in a minute, for rational inequalities are actually really good. So let's go ahead and read them before we apply them. It says steps for solving. Move all terms to one side and let p of x be equal to 0. So we're going to set everything to one side and then the other side is just going to be equal to 0. Solve the polynomial by factoring or graphing to find the roots. These are what we're going to use as boundary points. We're going to draw a number line and mark each root or boundary point correctly on the number line. We're going to pick test values in each area between the boundary points and decide whether those values are true or false in the original inequality. And that's really important that we're always going to refer back to the original inequality. The answers will be the areas that make the inequality true. And then we're going to write our answers in interval notation. And it says that remember, if it's strictly greater than or strictly less than is used, then you will use round parentheses. And if it's greater than or equal to or less than or equal to, then we're going to use these square brackets. All right, so let's see how we can do this here. First off, as x cubed minus 3x squared plus 2x is greater than or equal to 0. First thing that we're going to try to do is we're going to try to factor this. We know that we can pull an x out of each one of these things, which is x squared minus 3x plus 2, and quantity times x. Now the question is can we factor what we have right here in these round parentheses? The answer to that is yes. This will factor to x minus 1 times x minus 2. It's greater than or equal to 0. All right, so far we haven't done anything new, right? Like this is the stuff that we could do in previous sections. But now what we're going to do is this. We're going to figure out which values are going to make each one of these things equal to 0, right? So which values would make these equal to 0? Well, we know that 0 is going to make it equal to 0, so we're going to put these on a number line. So we can say that 0 would make it equal to 0. If we plugged in 1, that would make it equal to 0. So therefore here, this is going to be 1. And if we plugged in 2, that's also going to make it equal to 0. So here, we're going to have the number 2. Okay. So I put them on a number line here. And now what we want to do is we want to pick test values and see if they work out. So here, if I pick some negative number, right, if I pick a test value from over here, say I pick the value of negative 1. Now what I'm going to do is I'm going to take this negative 1, I'm going to plug it back into the original equation. So here then, if I choose negative 1, we're going to get negative 1 cubed minus 3 times negative 1 squared plus 2 times negative 1. And now if we plug these things in, this value right here is going to be a negative value. So I'm going to say in this area right here, it's going to give us a negative value. Right, if you do all this out, you're going to get some negative value. Let's see, this is going to come out to negative 1 minus 3 minus 2. So this is going to give us negative 6, and negative 6 is definitely negative. And we're only caring if it's positive or negative right now. Now I want to pick some test value from over here, say 0.5. 0.5 is between 0 and 1. I'm going to do the exact same thing now for 0.5. I'm going to plug it into our original polynomial. So we're going to have 0.5 quantity cubed minus 3 times 0.5 squared plus 2 times 0.5. Now, if you do this, this is going to give you 0.125 minus 3 times a quarter is 0.75 plus 2 times 0.5 is equal to 1. So here, this is going to come out to 0.325. Did I get that right? No, 0.375. Either way, it's positive, so we're going to say that this area right in here is positive. We're going to do the same thing right here. A test value in between 1 and 2 is going to be 1.5. And again, you can pick any value that you want between 1 and 2. picking the number 1.9 is just as good as picking the number 1.5, which is just as good as picking the number 1.1 or 1.001 is also completely fine. I'm just choosing 1.5 because those are going to be easy values to do. But now, just like we did before for -1 and for 0.5, I'm going to also do it for 1.5. I'm going to do that one up here because I'm kind of running out of room. 1.5 quantity cubed minus 3 times 1.5 squared plus 2 times 1.5. I'll let you figure out what that actual math comes out to be, but one of the things that we can see right here for sure is that this is going to be negative. And again, right now I'm only interested in see if it's positive or negative. And now we have to pick our last test value. It has to be above 2, so the number 3 will work out just fine. And if I go through that same process, 3 cubed minus 3 times 3 squared plus 2 times 3, we're going to see that in here that this is going to be positive. All right. So now we went through, we figured out what our factors are. We figured out what numbers we would have to plug in to actually get those equal to 0, which is 1, 2, and 3. And in between here, right, in these sections, we pick test values and plug them all back into our original equations, which is how we got this work up here. But now we see this. We want it to be greater than or equal to 0. So greater than or equal to 0 is only going to work in this section right here and in this section right here, because those two sections are positive. If we want it to be greater than or equal to 0, we can't have areas where we're getting negative values from. So therefore, where this is true is going to be from 0 to 1, and then a union with 2 to positive infinity. Now I left away the brackets and the parentheses for a reason, because up here it says that if it's greater than or equal to or less than or equal to, we're going to use these square brackets. So that's why, since here we have that it's greater than or equal to, we're going to use square brackets for these. But remember, the infinities always get the round parentheses. All right. So we're going to do exactly what we just did for the first one. We're also going to do it for example number 2. But now in example number 2, see that we first want to have everything move to one side and only 0 on the other. So I'm going to move everything to one side and only 0 on the other. I'm going to move everything to the left-hand side, so I'm going to add x squared to both sides. That's going to give me 2x squared, then plus 5x, and then here I need to subtract 3 from both sides in order to get this right here. All right. Now what we want to do is we want to factor this stuff. Again, this factoring is something that we learned in a previous section. So here if we factor this, this is going to come out to x plus 3 times 2x minus 1. It's going to be less than 0. And now what we want to do is, we want to figure out which values of x are going to make these equal to 0. Well, the values that of x are going to make it equal to 0, we're going to put those on a number line. It's definitely going to be -3, because we can plug in a -3 right here. And what value can I plug in right here so that this is equal to 0? 1/2. So therefore, I'm going to put that on a number line. So now we have our 2 boundary points, and now we just need to pick test values in each one of these sections, and then put those test values back into our original equation. Alright, so we want something less than -3. Here I'm going to pick -4. Want something between -3 and 0. Here I'm going to pick, -3 and 1/2. I'm going to pick 0. And we want something that's greater than 1/2, so here I'm going to pick 1. Now, if you do these, right, so if you take this now and put it back into the original equation, we're going to try to see if -4 quantity squared plus 5 times -4 is strictly less than 3 minus -4 quantity squared. If we do this, we're going to see that, well, let's do it. Here, negative 4, this is 16 minus 20. Is that less than 3 minus 16? So is negative 4 strictly less than negative 13? Nope. So, nope. That section, oh, let me scroll up a little bit. So here we just did that. This is 16, this is negative 20, this is 3, this is minus negative 4 squared, which is 16. The question was, is negative 4 less than negative 13? No, so I'm going to write no right here. Now we're going to do the exact same thing with 0. We're going to plug 0 back into our original equation, which gives us 0 squared plus 5 times 0 is strictly less than 3 minus 0 quantity squared. Well, this right here is going to give us 0. Is 0 less than, strictly less than 3? Yes. Now, for our last test value, here we have 1. Again, we're going to take this 1, we're going to plug it back into our original equation, and we get 1 squared plus 5 times 1. Is that strictly less than 3 times negative 1 quantity squared? So here we're going to get 6 strictly less than 2. Is 6 strictly less than 2? No. So therefore, the only section that works is just from negative 3 from negative 3 to 1/2. So therefore, we're going to go from negative 3 to 1/2. Again, I'm leaving off the parentheses and the brackets because if we go back above here, we see that whenever we have strictly greater than or strictly less than, we get the round ones. And here in this problem, we do have strict inequality. So therefore, the only interval that works for this is going to get round, which is going to be between negative 3 and 1/2. All right, so that's the first one for polynomial inequalities. So here we were always dealing with polynomial inequalities. Now what we're going to look at are rational inequalities. And again, a rational inequality is some kind of rational expression. But now this rational expression is going to have some kind of inequality signs. But the process that we go through this is actually really, really similar. We just take it piece by piece. We first look at what's going to make the numerator equal to 0. And we also look to see what's going to make the denominator equal to 0. And then we'll put those things on a number line. But just like we did before, let's briefly go through this definition, because these steps are pretty good. It says move all terms to one side so that the other side of the inequality is equal to 0, which we already have right here. Simplify the rational expression using common denominators or factor if it's just a fraction. So we look something like this. So we want to get rid of the common factors. Find all the roots from the numerator and all the vertical asymptotes from the denominator. These will be your boundary points. So again, here it's simply just going to be the roots and whatever makes our denominator equal to 0. We're going to draw a number line and mark all the boundary points, which was what we also did in the previous problems. Pick test points in each area between the boundary points and decide whether those values are true or false in the original inequality. So we're going to take it back to the original. Again, this right here is really important, original inequality. And the answers will be the areas that make the inequality true. Again, write your answers in interval notation. But here now we get this. If we have greater than or equal to or less than or equal to are your inequalities, then the roots get the squares, but the vertical asymptotes get the rounds. But if we have strictly greater than or strictly less than, then we're just going to get rounds for both of them, or any of them. All right, so let's do it. What makes our numerator equal to 0? Well, x equal to 4 makes our numerator equal to 0. What makes our denominator equal to 0? X equals to negative 1 makes our denominator equal to 0. Those two obviously don't have any common factors, so therefore we can just plot those two numbers down on a number line and start picking test values. Here I'll pick negative 2, here I'll pick 0, and here I'll pick 5. If we do this, right, if we do it again just like we did for in the previous problem, if I do it for negative 2, it's going to be negative 2 minus 4 divided by negative 2 plus 1. If we do this, this is going to be negative 6 over negative 1, which is just equal to 6. Is that greater than or equal to 0? Sure is. Therefore, this is positive, or I can just write it as yes, whichever way that you liked better. If you pick 0 now, we're going to get minus 4 divided by 1. Is that greater than or equal to 0? Nope, that's negative, so we're going to say that that doesn't work. And here for 5, we have 5 minus 4 over 5 plus 1. This is going to give us 1 divided by 6. Is that greater than or equal to 0? Yeah, that's positive. So yes, it is greater than or equal to 0. So therefore, the two sections that work are these two that now have arrows above them. If I want to write this in interval notation, we're going to go from negative infinity to 1, and we're going to union that with, we're going to then go from 4 all the way up to infinity, and infinities always get the rounds. All right, now I left the brackets or parentheses away here again because this 1 would make our denominator, I'm sorry, this should be a negative 1. This negative 1 makes our denominator equal to 0. So therefore, we can't keep this negative 1, even though it's greater than or equal to, because this would make our denominator equal to 0, we cannot include this in the interval of values that would work for this rational inequality. However, 4 is completely okay, and since we have greater than or equal to, this one right here is going to get the square. So that's what it means right here. If it's greater than or equal to or less than or equal to, the roots get this, but the vertical asymptotes, what makes our denominator equal to 0, still just gets the round. And since negative 1 makes our denominator equal to 0, it still gets the round. All right, let's do this next one. We can factor this to x plus 5 times x minus 5 over x minus 8. We're saying that this is less than or equal to 0. I'm going to scroll up so you can see it. Just like we did before, we're going to figure out what makes our numerator equal to 0, what makes our denominator equal to 0. So here we can have that it's either going to be negative 5 or 5. Here it's just going to be a positive 8. We're going to plop those down on a number line, negative 5, 5, and 8. We're going to pick test values in these areas right here. So here we can use negative 6, for instance. Here we can use 0. Here we can use 6. And here we can use 10. If you go through it the exact same way, take these values, plug them back into your original equation, and see if that is in fact less than or equal to 0. We'll do the first one together, but then for the next ones, I'll let you figure those out by yourself. And again, you can pick any test values that you want in these sections. Any value between negative 5 and 5 will do. I picked 0, but you can pick 1 if you like number 1 better. But we'll do the first one together. We're going to have negative 6 quantities squared minus 25 divided by negative 6 minus 8. That's going to say that this is 36 minus 25 is 11 divided by negative 6 minus 8 is negative 14. Is that, let me scroll up a little bit, is that less than or equal to 0? It sure is. So therefore we know that this is negative and this works. Now if you go through these test values for all these other ones, you're going to see that this is positive, so therefore it doesn't work. This is negative, so therefore it does work. And this is positive, so therefore it doesn't work. And the reason why the positives and negatives don't work is we want all of this to be less than 0. Less than or equal to 0. Less than or equal to 0. So therefore, if it's negative, it is less than or equal to 0. So that's why I'm saying yes, it does work. If it's positive, it's not less than or equal to 0. So that's why I'm saying no, it doesn't work. So therefore, the sections that are going to work are going to be this section right here that work, and this section over here. So we're going to go from negative infinity all the way up to negative 5. And we're also going to union that with from 5 to 8. Alright, and once again I left the parentheses away because we have to make sure that whatever makes our denominator equal to 0 gets a round. Well, here 8 is going to make our denominator equal 0, so that gets a round. Now what we have to do is we have to check to see if we have greater than or equal to, or less than or equal to, and we do. So therefore, whatever doesn't make our denominator equal 0, those are going to get the square. Alright, so that's for number 3 and number 4. Finally, the last problem for the lecture videos. It's exciting. Last problem for the lecture videos. Asks us to do a little bit of extra work here, because again we want to bring everything over to one side and have the other side equal to 0, which means that we have this right here. Now the problem is that we don't have common denominators, so the first thing that we have to do is get a common denominator. The way that we get a common denominator, oops, that almost turned into a 3. The way that we get a common denominator is we're going to multiply this by x plus 3 over x plus 3, which is just the same thing as multiplying this 2 by 1, right? So this right here is just the same thing as 1. So if we multiply this 2 by it, we can multiply it by 1, which is completely fine. Now you might be wondering, well, why does that help us? Well, if I rewrite this as 2 over 1, which is still just the same thing as 2, now I have x minus 2 over x plus 3 minus 2 times x plus 3 over x plus 3. But if this is divided by x plus 3 and this is divided by x plus 3, I can put it all over x plus 3. So now I'm left with x minus 2 minus 2 times x plus 3. And all of this is still greater than or equal to 0. Alright, well now what we can do is we can simplify the numerator. I told you it's going to be a little bit of extra algebra up here. If we simplify this, this becomes x minus 2 minus 2 times x minus 6, right, because this negative 2 distributes inside, over x plus 3. And now if I combine like terms, this is going to end up being negative x minus 8 over x plus 3, which is greater than 0. And this is the format that we wanted to have it in, right? We wanted to have it something where we can have a numerator and denominator. This is now a rational inequality. So now we can see what makes our numerator equal to 0, what makes our denominator equal to 0, put it on a number line, pick test values, plug those in to see if the inequality holds, and then write it in interval notation. So let's do it. What's going to make our numerator equal to 0? Well, we want this over here to be a positive 8. So therefore, x being equal to negative 8. We plug in negative 8 right here. Negative becomes positive. So that's going to make our numerator equal to 0. And here, x minus 3 is going to make our denominator equal to 0. Put these two things on a number line, negative 8 and negative 3. Pick test values. Here you can pick negative 9 or negative 10 or whatever works out best for you. Here we'll pick, say, negative 5 because that's in between those two. And here you can pick out 0. With those test values, now you're going to take these and you're going to plug them back into your original equation. That's super, super, super important. Plug it back into your original equation. And if you plug it into your original equation, you'll see that the only section that works is this middle section right here. So therefore, if we write it in interval notation, we're going to go from negative 8 to negative 3. But here, since we have strict inequality, both of these get round brackets. All right. So I didn't actually plug these test values back in. I didn't do that arithmetic for you. But I think you're good to go with that to see that this is the only section that works. All right. So this concludes the lecture videos for B9 and also lecture videos that I'm going to post for tomorrow.